All right, number 1 is telling us to name the quadrant in which the angle theta lies. And you're told that the cosine of the angle is greater than 0. So that means cosine is positive. And at the same time, the tangent of the angle is also greater than 0. So tangent is positive. So I'm going to look at my quadrants, and I'm going to find on my reference sheet, and I'm going to look for where is cosine positive and tangent positive. Okay, so cosine is positive in quadrant 1 and quadrant 4, and tangent is positive in quadrant 1 and in quadrant 3. So the only one that is got 2 circles in it is quadrant 1. So that is my solution. All right, an angle theta is an acute angle. The sine is 6/7. Use the Pythagorean identity, sine squared plus cosine squared equals 1, to find the cosine. All right. Okay, so the Pythagorean identity says if I take the sine, which is 6/7, and square it, and I add the cosine squared, which I don't know, so I'll just leave it cosine squared, that's going to equal 1. Okay, so 6 times 6, 36. 7 times 7, 49. And now I want to subtract 36/49 from both sides. And I'm going to get cosine squared theta equals, so I've got to do 1 minus 36/49. So I get a common denominator, which is 49. Okay. So to change this 1 into a denominator of 49, okay, I'd have to multiply the bottom. The bottom would be 49, and I'd have to multiply the top by 49. So that gives me 49 minus 36/49. All right, so 49 take away 36 is 13. So this is going to be positive, I'm sorry, 13/49. Now we take the square root of both sides. So I have cosine squared theta, 13/49, and now I'm going to do the square root of each term. And I get cosine. Those undo each other. And then I got the square root of 13, which I can't simplify, over the square root of 49, which I can. And that's root 13/7. Oops, that should be root 13. Seven, get rid of that guy. Here we go. All right, now You could do the exact same thing that we just did on this problem to get this answer. The only thing that you do different is that you're told that the angle is in quadrant 2. So in quadrant 2, my answer for cosine is going to be a negative number. All right, so for number 3, I'm going to treat this just like I did number 2. So I'm using my Pythagorean identity again. And that identity, guys, is listed on your reference page. Okay, so if you look through your reference page, you should see a little table that looks like this. That's got your Pythagorean identity on it. All right, so I'm going to take, so I got 24 over 25 squared. Okay, square it. So 24 squared is 576. Let's see, 24 times 24. Yep, 576. And 25 times 25. And then subtract this fraction from both sides. And here I have 1 minus 576 over 25. All right, so what I'm going to do that subtraction is turn the 1 into 625 over 625. Okay, and subtract my numerators. Okay, 625 minus 576, and that gives me 49. Cosine squared theta. Now take the square root of both sides. And I end up with cosine theta, whoops, just cosine, no, not cosine squared, equals 7 over 25. Now, when you go back to do the answer, it says theta is in quadrant 2. So in quadrant 2, cosine is negative. So this answer is going to be negative 7 over 25. All right, now we're going to use the fact that tangent is the same as sine over cosine to get this solution. All right, so we're going to take our sine and our cosine and use it to get tangent right there. All right, so this is number 3 still. So we know cosine is negative 7 over 25. Okay, sine is 24 over 25. And we're in quadrant 2, so when we're done, quadrant 2, the tangent is going to be a negative value right there. All right, so we go back up here. Tangent equals sine over cosine. Then I flip my denominator because I'm dividing by a fraction, so I multiply by its reciprocal. Can do some canceling here. I get 24 times negative 1, negative 24, 1 times 7 over 7, and that is my tangent. Okay, the cotangent now is just that flipped. I flip it, the sign stays the same. Okay, so this is now going to be, I'm going to have negative, still negative, and now flip my numerator and denominator. Okay, secant is the reciprocal of cosine. So I flip negative 7 over 25. So my secant is going to be negative 25 over 7. And then my cosecant, I flip sine. All right, so for cosecant, that's going to be 25 over 24. Okay, and if you forgot your ratios, okay, all your ratios are on your reference sheet. What makes your sine, what makes your cosine on your reference sheet. What I mean was we were looking at, here's your sine, cosine, tangent, and then here's how you get their reciprocals. All right, our next question is just like the previous one. Okay, so we've got 3 questions that are about the same. Okay, now what I know though is that I'm in quadrant 3. So when I'm doing my signs here in a minute, when I'm filling these out, I'm going to be following these rules right here from where what's quadrant 3 is part of, right here. Okay, so I took the Pythagorean identity, plugged in my values, and now I'm going to solve this. Okay, so I want to do 1 minus 9 over 25. So that's going to be 25 over 25 minus 9 over 25, which is 16 over 25. Okay, square root. And I get 4 over 5. Now look at quadrant 3. Sine is going to be negative. Right? So when I fill these in, I got cosine negative 3/5, sine negative 4/5. Tangent, okay, tangent is sine over cosine, right there. So that's going to be times negative 5/3. Those cancel the ones. Negative times negative is going to be positive, so I'll have 4/3. And I check those negative, negative, positive. All right. Okay, now to get the reciprocals, I got secant. Sign stays the same, flip the fraction. Cosecant, sign stays the same, flip the fraction. And tangent, or cotangent. And there's my values. Okay, number 5, you're given sine and cosine, and you're asked to find the exact value of each of the remaining 4 trig functions. So we're just going to use these charts up here. So if I want to get the reciprocal of sine is cosecant, so I flip it. The reciprocal of cosine is secant. So it's negative, it stays negative, and I flip the numerator and denominator. Okay, to get tangent is the sine divided by the cosine. So this is going to be a negative fraction times negative 5/4. The 5's cancel. And I'm going to have negative 3/4. And that's going to make my cotangent negative 4/3. So this question says use the fundamental identities and or complementary angle theorem to find the exact value of the expression. Do not use a calculator. So here's my expression, and what I did was I recognized that sine over cosine is the same as tangent. So I can rewrite this sine 29 over cosine of 29 degrees as tangent of 29 degrees. Now these two are the same. So when you subtract something that's the same, you're going to end up with 0. All right. Number 7, we're doing the same thing. We're using these identities. So the sine of 10 degrees times the cosecant of 10 degrees. All right. Well, if I look at my chart up here, I can see that the cosecant of 10 degrees would be the same as 1 over the sine of 10 degrees. Now multiply straight across, and I get the sine of 10 degrees divided by the sine of 10 degrees, and that's going to equal 1. Okay, and now our last one. All right, the tangent of 66 times the cotangent of 66 degrees. Well, if we look at our identities, cotangent is the same as 1 over tangent. So I can rewrite this part as 1 over the tangent of 66 degrees. Multiply straight across, and I get the tangent is 66 in the numerator, and the tangent is 66 in the denominator. And when those are the same, so when I divide them, I'm going to get 1. And that's review number 3. 1 to go, and we're done.